When you write JavaScript code, it looks simple. You write a function, call it, and it runs. But behind the scenes, there's an entire system working together to make that happen. In this video, you will see how JavaScript actually runs your code, using the call stack, APIs, task queues, and the event loop. First, an important truth: JavaScript does not work alone. JavaScript itself can only execute code and manage the call stack. But things like timers, network requests, or file operations are handled by the runtime environment. That environment could be a browser, or nodejs. At the center of JavaScript execution is the call stack. The call stack is where functions are placed and executed one by one. When a function is called, it gets pushed onto the stack. When it finishes, it gets removed. JavaScript always runs one function at a time from the top of the stack. That's why JavaScript is single-threaded. Now imagine you call setTimeout or make a network request. These operations take time. If JavaScript handled them directly, the whole program would freeze. But that doesn't happen, because those tasks are not handled by JavaScript itself. When you use setTimeout, fetch, or file operations, JavaScript sends that task to Runtime APIs. In the browser, these are called Web APIs. In Node.js, they are Node APIs. They handle the waiting part, while JavaScript continues running other code. Once an async task finishes, it does not go directly into the call stack. Instead, it goes into a task queue. There are two main types of queues. Macro tasks are larger scheduled tasks, such as setTimeout, setInterval, UI events, or I/O operations. These tasks are placed in the macro task queue. Macro tasks are not defined by the JavaScript language itself. They come from the runtime environment. Microtasks are smaller, high-priority tasks, such as promise callbacks, async await resolutions, or queue microtask. These go into the microtask queue. Microtasks are defined by the JavaScript language itself, and they always run before the next macro task. Now comes the most important part, the event loop. The event loop continuously checks the call stack. You will often hear this phrase: when the call stack is empty, the event loop moves tasks from the queue. But what does call stack empty actually mean? It does not mean after every single function finishes, because inside one script, many functions can call each other. Instead, it means this: the call stack is empty only after the entire current synchronous execution has finished. For example, if function A calls B, and B calls C, the stack becomes empty only after C finishes, then B, then A, and there is no more synchronous code left. Only then does the event loop run tasks from the queues. When the call stack becomes empty, first, all microtasks run. Then the next macro task runs. And the cycle repeats. Here's the complete flow. The call stack runs synchronous code. Async tasks go to Runtime APIs. When finished, they enter task queues. When the stack is empty, microtasks run first. Then the next macro task runs. And the event loop continues this cycle. If you want to see this process step by step with real code, watch the visual walkthrough video linked in the pinned comment. Subscribe for more tech explained simply.